Okay, now I am going to show you how you go from the sizes you measured in a set of sieves or possibly retrieved off a laser diffraction analyzer that give you the amount of sediments in a size class and convert that to the cumulative probability numbers that we need to make the graph we just saw. Here are some sample numbers. So here is, say, the -1 phi sieve, and 6% of the sample is coarser than that. The 0 phi sieve, 12% of the sample is coarser than that. The 1 phi sieve, 18% of the sample is coarser than that, and so on. So the first thing to do is see if the samples add up to 100%. They ought to come up to something close to 100%. So if I just say equals the sum, this is in Excel, of all of these, they should come out something close to 100. And in fact, they do. Normally, that is something that won't exactly come to 100 because of the inaccuracy in your measurements. Often you come up at 98, 99, 99.5%. So the first thing to do is, this is stuff that's coarser than -1 phi, and it therefore isn't stuff that is -1 phi. So if we grouped it all at -1 phi, we'd be wrong. Here's stuff that is between -1 and 0 phi, making up 12%, and that we should not group at 0 phi. If we do that, all our measurements will come out too small. So the first thing to do is, for each sample, calculate the sample midpoint. And the first thing I'm going to do is start over here, and halfway between -1 and 0 is -0.5. So a good representation for the sizes, sorry about that, of the sizes of this sample between -1 and 0 is 0.5. Similarly here, it's 0.5, 1.5. So you find the number that's halfway between all of your sample locations. There you go. So, and the one that's tough, actually, is this one here, because that's everything coarser than -1 phi. And we'll just pretend that we had the -2, the -3 phi samples, and nothing fell into those. So that would then be -1.5 phi. And in fact, usually that's what you do. You start with sieves that are coarser than your sample, so that you know where your sample starts. So now we have the percentage of samples in each category. We have the sample midpoints, and now we're going to get the cumulative weight percent. And that is, in this case, 6. 6% of the sample is coarser than -1 phi. Well, what's coarser than 0 phi? Well, 12% plus the 6% that was, turn it into a formula. Now I messed it up. Silly Excel. Okay, equals 12 plus, there we go, the 6% we had before, or 18%. what's coarser than the 0.5 fee? Well, 18% plus, remember the equals this time, plus the sizes that are smaller. So 36%, and so on and so forth. So that'll equal 24 plus 36. And now I can actually just copy this over to the end. And you see it ends up at 100%. So here is how we create the cumulative probability. Now, sometimes your samples start off as I represented here in percent, but often you have samples where you're just given a weight. So, for example, you might have 10 grams and 15 grams and 25 grams and 8 grams and 2 grams. How do we calculate the percent that each one of these makes of the samples? Well, and that would get us up to here, where everything adds up to 100. Well, if we add all of these up, we come up with a total of 60. So there's 60 grams in this sample. So what percent of that is 10 grams? And there's a simple equation to do that. You just say that's equal to 10 grams, divided by the total of 60 grams. There you go. And therefore, so it's 16%. And in Excel, there's a cool way of doing equations that I will show you now, where is if you do equals 15 divided by 60, or G6, the 60, and use the cell. If I put a dollar sign in front of the G, it doesn't move. And that way I can just simply copy this and paste it, and my numbers come out correct. Notice that they're in not percent, but in proportions. If I want to convert them to percent, I have to multiply by 100. If I take this here, I'm having to go off screen to do it, and multiply it by 100, I get 16%. If I take 0.25 and multiply it by 100, I get 25%, and so on. And if I go to my equation with the dollar sign and multiply that by 100, I can just copy it through. And then fix the error I made above, where I multiplied it by an extra thing. There we go. We end up, you'll see all of these now add up to 100 instead of 1. So now these numbers are in percent. So you just take the sample weight, divide it by the total weight of the sample, and that gives you the percent of sample weight. Then we can go back up what we did before, compute sample midpoints, and get the cumulative weight percent. And I'll show you in the next section how we can graph those sample weight percents and how we can then calculate mean